Hi Year 11, so let's start off with a retrieval roulette. So here's your questions, pause and get those answered, thank you. And here's your answers. So mark in a different coloured pen, fill in anything that you missed out or correct anything that is wrong. Okay, so last lesson we were doing these questions here on page 183 and 184. I'm going to go over the answers to these. And but before that, I'm just going to do a wee quick recap on what we have been looking at in forces so far. So we've looked at Newton's first law and Newton's second law. Newton's first law is that if the forces are balanced on an object, then it's just going to keep doing whatever it is doing. So in the absence of unbalanced forces, an object will continue at rest, or if moving, it will move with a constant velocity. But basically that just means it'll just either be staying still or going at a constant velocity if the forces are balanced on it, okay? And we can use that quite often to figure out like little missing forces in questions, and it actually comes up in quite sneaky ways. Now, Newton's second law, F equals ma. If there is an unbalanced force on an object, then the acceleration is going to be directly proportional to that and inversely proportional to the mass and in the direction of the resultant force. So if I try and state it properly, acceleration is inversely proportional to the mass of an object, directly proportional to the unbalanced force or resultant force, either's fine, and takes place in the direction of the unbalanced force. So if there is a resultant force acting on something, if the forces are not balanced, then an object's going to be accelerating, and it's either going to be accelerating or decelerating, okay? And mathematically that is F equals ma. So last day we were taking that information and we were putting it to use into some questions, and we're just going to go over those answers here today, okay? So for question 1, what force is needed to give a mass of 10 kilograms, an acceleration of 2 meters per second squared? So that's just F equals ma. Mass is 10, acceleration is 2, so 20 newtons for that one. So you be marking your work here for me, please. 2. What acceleration is given to a mass of 0.5 kilograms by a resultant force of 4 newtons, and we had to get the acceleration. So F equals ma. Either substitute in like that and then rearrange, or rearrange and then substitute after. Either way, I'll do both. So 4 equals 0.5a, divide both sides by 0.5, and you're going to get 8 meters per second squared. Or you could have done a equals F over m. If I just rearrange this to make a be the subject, the force is 4, the mass is 0.5, so we get 8. Okay, 3. What is the mass of an object that accelerates at 3 meters per second squared when a force of 15 newtons is applied? So again, we can do either. Just start off with our original equation, substitute in our values, 15. Divide both sides by 3, we're going to get a mass of 5 kilograms. And again, we could have started off with that rearranged, m equals F over a. So 15 over 3, which is going to get us the 5. Okay, now those ones were nice and straightforward. From like 4 onwards, they did start to get a little bit more awkward, so we'll slow down a bit for going over those. So, for a car of mass 800 kilograms, accelerates from 5 meters per second, so that's u, to 25 meters per second, that's v, in 10 seconds. Part A is asking us to calculate the acceleration. So we have u, v and t, so we can use a equals v minus u over t. So v is 25, u 5 and t 10. 25 take away 5 is 20, divide by 10, we get 2. Okay. Part B, calculate the resultant force. So now we have the mass and the acceleration, so we can put that into F equals ma. Mass 800, acceleration 2, so we get 1,600 newtons. Okay. 5. I already have this stuff written down because do you remember last day I went through these before you were doing them, so that's why it's there. But a car driver of mass 60 kilograms is in a crash. he decelerates from 20 meters per second, so that's U, to rest, so V is 0, in 2 seconds. Calculate his deceleration and then the force exerted on him. So same as the last one actually. For part A, we're going to use A equals V minus U over T. So A is 0 minus 20 over 2. So that gets me an acceleration of minus 10 meters per second squared. So a deceleration of 10 meters per second squared. For part B, we have to calculate the force. So we're going to use F equals ma. Now, the mass is 60. Whenever we're putting our...
I don't see a Sammy in your...
sorry. Whenever we're putting in our acceleration here, now, if I put my acceleration in as minus 10, that's going to give me a negative value for my force. But don't worry about that. That negative just tells you the direction of the force, because this person's moving forward and the seatbelt is pushing them back. So that negative is just showing you that that force is acting in the opposite direction. In an exam, they'd probably accept both answers, the positive and the negative. I'm just going to put it in as a positive number. So I'm just going to put it in as 10 to get my force of 600 newtons. If you have minus 600 newtons there, mark it right, okay? The minus is just showing you that the direction is opposite to the direction of motion of the person. Okay, hopefully that makes sense. Right, 6. A supermarket trolley has a mass of 20 kilograms. When pushed by a force of 15 newtons, oh here, I wonder why I didn't write that down. It accelerates at 0.5 meters per second squared. Calculate the resultant force on the trolley that gives it this acceleration. I'm going to ignore this diagram for now, okay? We've got the mass and the acceleration. So the mass is 20, the acceleration is 0.5. So my resultant force must be 10 newtons, okay? Now, part B is what people often find difficult. What's the friction force on the trolley? So we know that the resultant force has to be 10 to give us this acceleration of 0.5, but we have been told that it's pushed with a force of 15. So if we have a 15 Newton force going this way and a friction force going back the way, and combined these give us the the resultant force of 10, then this friction force has to be 5 newtons. Does that make sense to you? I think you will just like that, like not showing the working out. I think you'll be able to see where I've got that from. This 15 and this friction force have to combine to give us this 10, so this has to be 5. Really, if I was doing my working out properly, I would write 15 minus friction equals 10, because this is the resultant. And then I would do my rearranging. I would bring this over to the side, take 10 away, and I'm going to end up getting the friction to be 5 newtons. Okay. Number 7 then. A car has a mass of 1000 kilograms and is travelling at 20 meters per second, so that's going to be my initial velocity. The brakes then exert a steady force of 5000 newtons. What is the deceleration? So we've got the force and we've got the mass, so we can work out the acceleration or the deceleration. So if I substitute in here, I'm going to try and fit this in around what I have. Divide by 1000, we're going to get 5 meters per second squared, and that is the deceleration. Okay. Now, for part B, how long does it take to stop the car? So it's asking us for the time. We know the starting velocity is 20. We know the final velocity, is 0 because it's stopping, because of this word here, stop. And we're asked for the deceleration. So it's going to be either one of these two. I'm just going to go A equals V minus U over T. So final velocity is 0 minus the initial velocity, which is 20. Don't know why I went for that one. I think the other one's going to be easier to use because I forgot to substitute in my A there. Sure, I'm going to need it. So, apologies. My deceleration is 5, so I need to make sure I put my acceleration in here as minus 5. Okay. over time. So if I multiply both sides of this equation by t, I'm going to get minus 5t equals minus 20. Divide by minus 5, I get 4 seconds. Now I was a wee bit all over the place there, so I'm going to do it again using this one. So if I use this, v equals u plus at. So 0 equals 20, and then substitute minus 5 for a, minus 5t. Bring this over the other side, we get 5t equals 20. Divide both sides by 5, we get 4 seconds. Okay, hopefully that made sense to you. Now, these next few pages are practicals. We're going to leave those for now, right? And we're just going to go over onto page 188. So, there's more questions here. I don't know if we'll get them all done today. I might split this into, like, do the questions over a couple of lessons so that you can do these and then I can go over them to help you with the rest of them. Yeah, that's a good idea. So, all I want you to do today is the questions on page 188. So there's 4 questions there. This wee summary will come in handy. I'll have a wee look over these and see if there's anything I need to point out to you. Okay, yeah, I've only just looked at the first one and I want to give you a couple of wee hints. So, question 1. A bicycle and rider have a total mass of 90 kilograms. Travel along a horizontal road at a steady speed. Steady speed means the forces are balanced. The force exerted by the cyclist is 40 newtons. Explain why the cyclist doesn't accelerate. Well, I'm just telling you this answer. It's because the forces are balanced. So that's Newton's first law. Then B, the rider increases the forward force to, what's that, 70? Yeah, 70 newtons. Calculate the acceleration. Be super careful here. So, see the way they told us that, I'll do 2 diagrams. Whenever it was going at a steady speed, the forward force was 40 newtons. That must mean, because it's a steady speed, that must mean that the friction forces were 40 newtons as well. Because if it's going at a steady speed, it has to be balanced. The forces have to be balanced. So that's how we knew that was that. But then it says the rider increases the forward force to 70 newtons. So now this forward force is 70 newtons. These resistive forces are still 40. And we have to calculate the acceleration. So for that, you will figure out the resultant force on this is going to be 70 minus 40, which is 30 newtons. Okay, so we did do an example like that a couple of lessons ago. It's in the notes, so do look back over your notes on this to help you. Right, let's see question 2. Okay, there's a wee bit of rearranging to do here. You've got the acceleration, you've got the mass, right? I would use those to figure out the resultant force. Okay, so use F equals ma to get the resultant force. You're told that the resistive forces are 400. And then you're asked for this forward force here, or the thrust, I'll call it TH, so we don't mix it up with the F and F equals ma. So these two must combine to give you that resultant force you've just figured out. Okay. 3, calculate the force of friction on a car of mass that, if it accelerates at that, when the engine force is that. So, again, we've got our 3000 newtons going forwards. We have to figure out this friction force here. So I would use this mass and this acceleration to calculate the resultant force. And then you have to figure out what the friction force is. It's kind of like 6b. Remember this one? It's a similar style question to this. Okay. I'm giving you too many hints here because these are tricky, but I do want you to give them a go yourself properly. Get the brains going again. Right. Let me see. So this one has got forces all over the place. Just look at them carefully. Think about what's going on, and that's that. I'll not give you any hints on that one. Okay. I think that is me. So if you do those questions on page 188 for me, please, then next lesson we'll go over these and we'll give the next ones a go. Okay, see ya.